Hi everyone, today I am going to present unsupervised contextual document representation. This is joint work from Ankur Gupta from IIT Kanpur and myself Vivek Gupta from School of Computing, University of Utah. So let's look at some motivation. Good natural language representation is essential for many tasks, basically categorization, information retrieval, textual similarities. We already have a variety of methods for getting good representation of words like word to egg, glove, and even contextual embedding like BERT. What about documents? So there are multiple approaches which are proposed, like which are based on local context, context sensitive learning, topic modeling, and even contextual learning like BERT and all. In this work, we focus on semantic composition, which is basically the task of composing the meaning of the larger piece of text, which is the document, by the meaning of the smaller piece of text, which we understand much better, which we have better representation like words. So we focus on simple semantic composition. So there are lots of efforts for document representation. Some of you have seen this slide before also on my work. So one is like graded weighted bag of words. You just basically average words which are there. You can even weight it by some graded approach. PSIF and other approaches do this thing. Then there's doc2vec kind of approach. Then there are topic modeling approach like topic word embedding, where basically you have embedding of word plus the corresponding topic associated, where you use LDA for doing this. Then you can even add some kind of context sensitive learning also on it. Then there is lots of deep learning approaches, which is basically LSTM, RN, and contextual embedding like Elmo and BERT, basically where you give the documents and then you basically fine tune them or basically get their embeddings and then average them. So we basically see the approach of simple graded weighted averaging, but this works very well for sentence embedding, but this doesn't work very well for document embedding. So our approach is basically using some recent work, which is SCDV plus BERT has a contextualization to get better document representation. So the idea is basically we combine two algorithms, which is BERT, which is good at document contextualization. We know what the meaning of word is based on the occurrence it is occurring. So it's very good at words and disambiguation, finding the meaning of words. And SCDV, which is very good at representing large text document. Basically, it's a very nice way of composing by partition averaging of the word vectors. So first let's explain what is SCDV doing. It's basically doing a partition averaging. For example, this sentence, data journalists deliver the news of data science to general public. They often take part in the interpreting the data model, creating graphical design, and interviewing the director and CEOs. For example, now this is the paragraph which is itself a document. And now we take all the documents which are in corpus and basically cluster them. They're embeddings of words. We find that some of these embeddings are shared. So basically what here see data 1 and data 2 is polysemic words. They are occurrence in multiple contexts. And the probability in the bracket basically represent the probability they belongs to that cluster. Now you can see there are like 5 clusters which we have, and you can see there's a particular kind of clustering which is happening or partitioning which is happening within a cluster. Now simple averaging, what we do is basically take the prominent words which are there in this sentence and just average them. Whereas partition averaging, which kind of SCDV do is, first is take the whole vocabulary of words within the corpus, contextualize it so that we have data 1, data 2, data 3 like this. Then it basically cluster them using a soft approach, and then it do a weighted averaging within a partition but concatenation across a partition. So it's like K cross D instead of D dimensional representation. This is a work shown by Mekala et al. And follow up PSIF and other approaches in 2021 to 2016 to 2021. So it's shown that this approach really works well, and it's very good for representing documents of larger length with having multiple topics and context switching happening too often. As you can see, now within a partition we are averaging, but across partition we are concatenating, as shown in the arrows with different colors. So within partition we average, but across partition we concatenate. This is SCDV, PSIF and other approaches, which is all based on partition based averaging rather than simple averaging. Now let's look at document contextualization, which is the main crux of BERT. The idea here is basically you have the same words occurring in multiple contexts. For example, here the stock of Apple has increased. Here Apple is more related to financial aspect, which is stock. It's a company aspect, where the other apple is basically like the fruits rather than the company. So in the company context, it's wrong. So it's a fruit context. So now the idea here, what we do is we take the raw docs and we basically contextualize it using the BERT embeddings. And this is idea which is inspired from Mekala et al., who used this in his Conway paper and meta papers to basically find wherever the words is occurring in multiple senses, and then deployed a mini clustering algorithm. This is the detail to basically get the embedding. I won't go in much in detail, but the idea is basically you apply BERT, you take all the, for a given word, you take all the embeddings which you get from the BERT for the last layers for that words in all its occurrences, and then you do a mini clustering, which is basically take, for example, apple wherever it's occurring and then cluster it, and the cluster will be like equal to the number of senses, which is roughly 2 to 6 kind of thing. And then each cluster center basically represent a symbolic meaning of occurrence of word in a particular context. So how many clusters represent how many contexts of that word is occurring in, and each centroid of this can be taken as a new embedding kind of thing. And now you can basically contextualize that document by saying, okay, this word is in which cluster, so I will basically assign it to that cluster. During the test time, you can do the same thing. You can get the BERT embedding and then see which cluster centroid is closer to that, and then you basically assign to that cluster. And obviously there is some parameters like why you use k-mean, so they argue it's very efficient, and also the cosine distance reduced Euclidean distance, so it's pretty much simpler. Also the threshold and all can be set pretty well, and it's most important, it's very efficient and fast, and it works pretty well in practice. So this is the overall algorithm, which is where we combine SCDV+BERT. We first take all the words which are there in the vocabulary, we find all their occurrences in the corpus, we basically contextualize them with BERT, and then basically we do a corpus contextualization. And this process actually occurs for every unique words in the corpus. So we find all its meanings using the BERTs, all meaning with respect to all the context which is occurring, and then we contextualize the document. Now what we have basically is k-v vocabulary, where k is basically number of average contextualization or average words which are present in this. And now what we can do is basically do our SCDV algorithm. We take all of these words as a different words, and the corpus is itself contextualized. So, and then we simply apply SCDV, which is take all the vocabulary words which are already contextualized, get the probability of belonging to a particular cluster for a given all the vocabulary words, get a word cluster vector, and then basically form a word cluster vector which we can use for later averaging and all. This process occurs for all disambiguated words in the corpus. So after contextualization for all the words, you can see more detail about the SCDV in the paper. I'm not going in depth, but the basic idea is you do a partition averaging. For that you need to do a secondary clustering using all the words which are there in the vocabulary after contextualization. And finally what you can do is you can multiply with this IDF weighted using all the cluster vector which are concatenated. So this is first we basically do assigning of the words to various clusters, and then we basically concatenate them the same words for various cluster where it's occurring, and then also IDF weighting. And finally you can average basically the words which are occurring in document. We just take their word topic vector instead of word vectors to average them. And remember here the word here is contextualized already, so if there's a penalty 1 and penalty 2 and penalty 3, they are considered as different words, not the same words. And basically then we do summation of all the words which are occurring in that document, their word topic vector, and this will give you a final document vector. So the last two step is basically very similar to the SCDV. The first step is basically of the contextualization using the BERT. So we are basically combining BERT with the SCDV algorithm to get better representation. And now let's look at some of the results. So results, as you can clearly see, SCDV+BERT outperform. We also did one more interesting operation. Generally what happens is there's a common factor, there's isotropic distortions which are there in this, and Ithya and other people have shown in the past that this distortion can basically lead to worse representation, and you can remove them from the word embedding. So we also did that. Actually we show result in a paper on both SCDV+BERT contextualized and plus and without isotropic this thing, and in both cases we actually outperform SCDV+BERT and also the BERT. So which is the major thing? So we basically outperform both the BERT vectors and the SCDV with the word-to-vec kind of approach. So as you can see, our performance is better than both the baselines models, which is SCDV plus word-to-vec without using BERT contextualization, but it's also better than the BERT pre-training without doing partition averaging kind of thing. We also have result in the paper where we just don't do the contextualization and just average all the BERT representation of the words, and we show that is not that efficient and good. So you can see the paper for more detail. So first of all foremost, we find that the BERT pre-train is not as good as it there compare if you do SCDV+BERT for many of the data sets, although it's competitive. Then we find that SCDV+BERT without any contextualization is good, but it doesn't beat word-to-word kind of baselines. It's not that much efficient, except for some data set like Amazon and 20 Nuzul, it's pretty competitive. But however, once we introduce contextualization and also add the anisotropic, then we outperform all other baselines which were there before. SCDV plus word-to-word, SCDV plus word without contextualization. And finally, we also compare with the fine-tuned BERT, and we found that it's even better at some cases with the fine-tuned BERT. Very competitive. For example, in Twitter, it's very substantially better. In other places, almost performs similar or sometimes outperform marginally. For example, in Amazon. The most interesting aspect of this work we want to show is also the effect of low resource embedding. We show that this approach is very good for low resource data set. So we experiment with 10, 20, 30% data set to simulate low resource, and we find with the limited resource thing, embeddings which are fine-tuned, which were earlier performing equally good or sometimes better than the SCDV plus contextualized BERT, is now performing very worse with the less amount of data. However, our approach, which is SCDV plus BERT plus anisotropic reduction, is pretty much stable. Although it's slightly less, it's obviously has increased the data, but it's not as far bad as this. Secondly, we are able to get the performance with just 40% data equivalent to the performance with original SCDV plus this thing, and also the performance with SCDV plus BERT contextualized 100% data. So it's not with 50% data, we are not far away with the 100% performance, and we originally built the best SCDV plus BERT based model using this approach. So we tried this on Amazon Twitter data and show that our approach is pretty much good and efficient and robust and stable. We also try what happens if we decrease the data too much, like if we have just few shot setting where classified training is not possible. Obviously, all models fails. Here, the performance gap between the original baseline with 100% data with SCDV and even BERT is BERT pre-train is very far away. However, the fine-tuned model doesn't work at all. But other models, it's not possible to train BERT fine-tune here because there is no training possibility. So the only possibility we can use all the unsupervised approach, and here we find that our approach is pretty much better than all other approach by significantly 8 to 9% at every k, and it obviously increases as we increase the k, and the gap also decreases as expected. We also try on other tasks like STS, which is semantic textual similarity. There also we find that our approach beat both SCDV plus word-to-word and BERT pre-train. We also try on another data set which is like relation linking between concept and related relevant project. You can see more detail in the paper. Here again, BERT pre-train, SCDV plus word-to-word, even SCDV plus word, just contextualization beat all of them. And then once we have anisotropic, we get even more significant improvement. So it's all outperform. So overall takeaway from this paper is basically you have contextual representations which are very good to get from BERT, and BERT is very good at that, so you can use that for getting better document representation. We found that the SCDV approach is very good for basically partition based averaging and is very nice strong baseline and have significant influence on document representation instead of simple averaging. Third is this anisotropic approach, which do isotropic reduction and distortion removal, is also very important for the corresponding downstream tasks. And lastly, we show that these three approaches can combine and you can get very efficient unsupervised document representation for large document, and it works pretty well. Lastly, we say that this approach is useful even low resource setting or setting where fine tuning is not possible, or fine tuning with the limited data is not working well. So which is the zero shot and the few shot, which is the few shot and the low resource setting experiment which we show. You can see the paper and all the source code to reproduce here. I'm happy to take more questions. See you in the conference. Thank you.